Hello and welcome to video 24 in my Rigging in Maya series. Well, when I was looking into these videos, I initially thought we could cover writing this script in just one. How wrong was I? We are now on to video 4, and in this one we will automate the creation of the roll joints and the associated systems. This will give us a great automatic limb rigging tool which we can use for this and other projects. It will also lead us nicely into the next part of our quadruped rig, where we will add the ribbons which the driver joints will ultimately drive. So I think this and the next video will be the last ones where we work on this script, but let's see how we go. I might add some more to it, if that's what everyone wants, or I may expand more upon this and just add them as part of my CG tips series. As always, let me know what you think. Before we get started, I just wanted to mention that you can now download all the source files for this and all my other courses from my QBrush, Coffee, Gumroad and ArtStation pages. You can find links on the screen and in the description below. I also wanted to tell you about the antCGi Club. Joining the club is a way for you to help support the future of this channel, as it will allow me to dedicate more time to creating new content just for you. But that's not all. You can also earn yourself exclusive rewards. These include all the course assets, models, rigs and custom made scripts, as well as access to the members only area of the antCGi Club Discord server. What's more, you can also claim a discount on all antCGi merchandise. There are two ways you can join. The first is to simply click the join button below this video and become a member of this YouTube channel. The second is to head over to my Patreon page and support me there. Alternatively, you can visit the link on the screen or in the description below to find out more. Okay, here we are again. So we have the same file we began with in video 23. So it has all the controls already built. Again, if you need help building your own controls, please see some of my earlier videos. Okay, so let's start a new section. I'll just copy this. Actually, let's have a quick recap of where we are with the script. So we select the root joint and run the script. So this has now rigged the rear leg for us. We can move it around, as you can see, and we can also make the leg stretchy too by adjusting this attribute. All this was covered in the previous 3 videos, so if you haven't watched those yet, I would highly recommend you do. We can also adjust the type of stretching we want. Okay, so let's undo all that. And copy this comment here and paste it here. We will also update this so we know what this section does. And make some room. Okay, so first, why do we need roll joints? If I rotate the femur, this way looks okay, and this looks good too. But if we rotate around the x-axis, it starts to look unnatural. You see, just like your own shoulder, this needs to twist from further down the joint. So we use roll joints to help offset that twist. Again, I do go into more detail and show how to set these systems up manually in my earlier roll and twist joint video. We can do the same with the ankle area too. So we transfer the Y rotation further up the joint. Adding these can also make the overall foot rotation more stable. Okay, so first we need to create some joints for us to work with. Let's start with a list. Let's call it roll joint list. This will have a list of the joints we want to build. We can also use it to dictate where our new joints will be created. Let's use the joint hierarchy list we created earlier in the script so we can reference the joints in the leg. I'll paste this here 4 times because we want 4 joints in initially. The first roll joint wants to be here where the femur is, so we set this to 0 because it's the first joint in the joint hierarchy list. For the next joint, we want the second roll joint, which will be at the ankle. So this will be number 1, 2, 3 in the list. With the last two in the list, we just want to reference the femur again, so set these to 0 too. So that's our list. Next we want to work through each of these joints one at a time, so let's use another for loop. We will use a for I in range one, just as we did earlier. But instead of using limb joints, we can use the roll joint list. Rather than using it directly, we need to tell Maya how many items are in the list. So we use len, and then roll joint list in parentheses. This will return the length of the list. So we are essentially saying for I in range 3. But remember, there are 4 items in the list, but the first item is 0. It's better to do it this way because we can easily add more joints to the list if we need them, and the script will adapt. What we need to do now is generate some names, but we need different ones depending on where we are in the list. So we need to add some checks. First, let's use if I is greater than. That's what this symbol represents. So this will check where we are in the list, and if it's third, run the following script. Remember that list numbers begin at 0, so third will actually be fourth. It does get a little bit confusing, but eventually you do get your head around that. Let's create a variable, roll joint name. So this needs to be the current joint in the list, so we use I. And let's just add follow tip to the name. Basically, we want this joint to be called the joint name, but with follow tip on the end. Now we are going to use something new. Instead of using else, as we have before, we are going to use elif. We use this if we are working with more than 2 options, so the code will check each in turn. This time we want to check if the item in the list is greater than 1. Because we already added a check for the last name in the list, that will be ignored, so this will only work on the third item. We are just generating names, so we can copy this code here and just change the name at the end. So this just wants to be follow. That will be this one. Okay, now we can use else because this is the last item we are checking. We don't need to use the I is greater like above because this will work on what's left if it isn't the third or fourth item in the list. So this will essentially work on the first 2 joints listed. These just want to be roll joints. That's the femur and ankle joints. Let's add a comment here. Now we have the joint names set, we can start to build some joints. We have done this before, so let's copy an earlier piece of the script and adapt it. Here we go. This will create a joint and move it into position. We use this to build the main joint chains. Paste it here. And we need to move it back so it's not in the if statement above. Just one indent though, it still needs to run in the for loop. We can change the name of the joint to our new roll joint name. I'm also going to use the rad flag and set that to 2. Here it is, radius. This will just make the joint bigger so we can see it better once created. Next we want to move the new joint so it matches the position and orientation of the one in the list. So let's update the name first. We don't want to check the joint hierarchy list though. Instead, it needs to be roll joint list we look at. And we leave it set to I in between the brackets. Finally, we use make identity to freeze the rotations, setting them back to 0 while maintaining the orientation. Okay, time for a test. Save the script select the root joint and hit the button. Okay, so we can see that some new joints have been created. Let's check the outliner. We have the joints and they are named correctly. They are also in the right place. The problem is they are parented to each other. If I change the manipulator to object instead of world, we can see that the joints are orientated correctly too. Let's fix the hierarchy. All we need to do is make sure they aren't parented to each other. And if you remember, we covered this in an earlier video. All we need to do is clear the selection after each joint is created. Okay, let's undo and run it again. You see, all the joints are now sitting in the root of the scene, which is perfect. Also, ignore this error which keeps popping up when I use the outliner. It's nothing to do with the script. It seems to be a little bit of a bug with Maya. I maybe need to try clearing my preferences, see if that fixes it. If you remember, we had the same issue in the previous video. Okay, let's undo again. So even though we cleared the selection, so each joint is separate, we now need to adjust the hierarchy so they are parented to the correct joints. We can do this as we did above, by checking where we are in the list and then parenting the joints. Let's do the roll joints first. This time we are going to use if I is less than 2. So this will only work on the first 2 joints in the list, the femur and the ankle. We just want to parent the roll joint name, which is the current joint being created, and we are parenting those to the main joints, so we can use the roll joint list. Now we want to use another elif statement, so we can do something else if it's not the first 2 joints. This time we are checking if it's greater than 2, so the last joint in the list. All we want to do now is parent the follow tip joint to the follow joint. So we use the same line of code, but change which joint we are parenting to. This needs to be set to 2 instead, because that's this joint. We also need to make sure it's the right name too, so add follow onto the end. Let's try this. That doesn't look right. Ah yes, that's right. We need to move the clear selection line to the end. Let's try that again. That looks better. So the follow tip joint is parented to the follow joint, which is just how we want it. Also, the joints are bigger too. This just makes them easiest for us to see. Okay, move that. And undo that. So what we're going to do next is make the rotational axes visible. This isn't a main part of the script, so you can delete it later. It's just going to help us see how the joints are rotating. To do this, all we need is the toggle command. If we take a quick peek at its flags, here we go, local axis. So let's use the roll joint name again. And then set local axis to 1. If I run that now, we can see the rotational axes. So if I rotate the joints, we can actually see what they are doing, which is going to be important as we progress through the video. Okay, we have the joints, so let's move on to the systems. And let's look at the femur first. So we created the follow joints, but they still need more adjustments. The tip needs to be moved away from the main joint, like this. And we ideally need them both to sit outside the leg. If we look in the output, we can see the command used to move the joint here. So we can implement that later. First, let's move the tip joint. To do this, we will use a point constraint. We don't want to change the joint's orientation, it's already set as we need it, with X pointing towards the next joint. All we need to do is change its position. If we use a point constraint, we can quickly move this joint so it's exactly halfway between the other joints. First we set the joints we want to constrain to. We can use the joint hierarchy list again to reference these. So we want the first and second joints in the list. This should be 0 for the first joint, and we copy this. This should now be 1 for the second joint. Now we tell it which joint we want to constrain, which will be the follow tip joint. I can copy the name here and paste it here and add tip on the end. Let's add our flags next. Weight 1, and we need maintain offset to be 0 because we want the joint to move between the other joints. What we are also going to do is give this constraint a name. We haven't done this before. We are doing this so we can quickly find and delete it once the joint is moved. Let's call it something temporary like temp PC. Okay, before we delete it, let's make sure it's working. So there's the tip joint and it's moved between the other joints. So that's working. If we look at the outliner, we can see the point constraint. We now need to delete it, otherwise it will cause problems with the rig later. We can do this with the delete command and just specify the name. Simple as that. Okay, next let's move the follow joints out slightly. All we're going to do is reference the move command we saw earlier. I'll just copy this name. But first we need some values. These are X, Y and Z. I'll just put 0, 0, 0 for now. And now the name. When building names like this, you can put them into parentheses if you like, but you don't always have to. I sometimes do it out of habit because I'm coming from a Mel background. Okay, let's see how far we need to move the joints. I'll move this out temporarily. This is good because we can see the flags we should use too. And the amount is roughly -7. So flags first. R equals 1, which is relative. OS equals 1, which is object space. And WD equals 1, which is world space distance. Let's add the value now. So let's call it -5 along the Z axis. Let's move that and run the script. So the tip's moved, but that's because we specified the wrong name. Just remove that and try again. That's much better. So the idea behind this is that the Z-axis will always point towards the follow joints. Well, not the joints themselves, but a locator which is parented to these. This makes the twist more stable and ensures it doesn't happen on the femur joint. Let's add the locator. We've already added a few locators so far in this script, so you should be used to using the command. Let's give it a name. We will set roll joint list to 0 so it references the first joint in the list, which is the femur. And we should change the name to roll aim. Now we need to relocate it. So let's use the match transform command again. You see, as your scripts start to get longer, they turn into a lot of copying and pasting. It just saves time in the long run. So we want the locator name first. And we want it to match the follow joint. Just as we did with the follow joints, we want the locator to move out. So let's copy the move command here and change the name so it's moving the roll aim locator. We will leave it set to -5, 2, just to make things evenly spaced. Let's run the script. There we can see the locator. Perfect. What we now need is for the locator to move with the follow joints, so we just need to parent it to them. Let's do this after we relocate it. Update the name so it's a locator. The second part, which is what we are parenting to, is fine as we need the locator to be parented to the follow joint. If we run that again, the locator follows, which is ideal. We use this setup to help prevent the joints from flipping. Because the roll joint is always aiming at the locator, we need the locator to move just so that the aim is more stable in extreme poses. Okay, let's now add in the aim. What we want is a roll joint to always aim at the fibula joint, so the next one down the chain. But we also want it to keep looking at the roll aim locator too, for stability. To do this, we can use an aim constraint. So this is set up just like other constraints, but we have a few more flags to work with. Let's add it manually first. I'll just open it up. And reset it. So here's the roll joint. And we want it to keep the x-axis pointing at the fibula. We also want the z-axis to point at the locator, as it is now. We just need it to stay as it is, but follow the locator and the fibula joint. To get it to use the locator too, we can set world up vector to object up and specify the world up object to be the roll aim locator. So if I select the fibula first and then the roll joint, we want the aim vector to be the x-axis, which it is already. The up vector will now control which axis looks at the locator, so we need it set to Z. We also need to invert it because the z-axis is currently pointing away from it, so we set the z-axis to -1. Okay, let's apply that. So here we have the code along with all the flags we need, so we can use this as a reference. If I move the locator now, you see the roll joint follows it, with the z-axis pointing towards it. Let's move the paw control. We can see that the roll joint is also following the leg too. So we can use the locator to keep the twisting stable here. Let's undo that and add the code to our script. I'll just copy the mel script down here so we can see it. As this is Python, we need to specify the joints we are working with first. So joint hierarchy 1 is the fibula, which we want the roll joint to aim at. Let's add the flags next. So weight equals 1. Next we have the aim vector. So that will be aim if we look at the flag list. Again, because this is Python, we have to put the values in parentheses. So that's 1, 0, 0, because we need it to aim down the x-axis. Next, the up vector, which is just U. Set these values to 0, 0, -1. This is the axis which will look at the locator. World up type is object. And then we need the name of the world up object. So that's the roll aim locator. But remember to use the name from the script, not the full name here. And we will tell it to maintain the offset too. Let's remove that now. We have an error. Yes, I need to close these parentheses. Let's run this now and see if it's worked. If I move the locator, yep, that works. Let's try the joint. Works perfectly. You see, the roll joint only follows when we rotate around the x-axis. What we now need is a way for the follow joints to follow the leg as it moves. This will mean the locator also moves with the leg. And again, we're doing this to keep it more stable and to prevent the joints flipping. To do this, we can use a simple IK handle. We want a rotate plane solver for this. So we need to create an IK handle and then snap it to the fibula joint. We then parent it to it so it moves with it. I'll make IK handles visible again and turn off polygons for now. We can see it now. Let's switch to FK. Now if I rotate the leg forwards and backwards, the follow joints follow it. If I lift the leg, it follows too, so does the locator. Now if I twist it, ideally we don't want the roll joint to twist, but it is. What we need to do is reset the pole vector, and this will stabilize it. So I'll quickly set these to 0. And we also have the code here, which we can incorporate into our script. I'll just copy that down here. Now if I rotate it around the x-axis, the roll joint is much more stable. So this means the upper leg will move forwards and backwards, in and out, but it won't twist. Now with the current model, this won't be visible because I skinned it to the driver joints, which are twisting. Ideally, you would skin it using the roll joints instead. So the femur roll instead of the femur. Let's undo all that and add it to our script. Bring back the polygons too. Let's create the IK handle first. I'll sneakily find a bit of code I used earlier. This has the rotate plane solver. So paste that here. Let's call this follow IK handle. The solver is already set. And update the start joint, so it's the follow joint. And the end effector is the follow tip joint. Now we need to move and parent it. Let's parent it first. And we can use match transform to move it. We just need to update the names. So we are parenting the IK handle. to the second joint in the joint hierarchy list. We also want to match the IK handle to the same joint. So that was easy. I'll just comment these out. Let's reset the pole vector. Copy this. We need the IK handle name. And we need to add the attribute onto the end. And set the value to 0. Copy this twice. And update the attribute to X, Y, and Z. So that's done. Delete this and let's test it. I'll switch to FK again. So, forwards and backwards works. In and out works too, with the roll joint following. Remember, it will be the roll joint that affects the model. Well, with this rig, it's going to drive the ribbon, and then the ribbon is going to drive the model. And if I twist, the roll joint stays nice and steady. As I said earlier, it's difficult to see it in action with this rig, but trust me, this will work. So that's the upper leg more or less done. So let's work on the ankle next. And the setup is very similar, so we can reuse some of the code we've already written. Let's add a few comments first. Okay, so we need another locator. This will influence the metacarpus roll joint. I'll just fix this comment with the right name. This time we need to use the second joint in the roll joint list. If you remember, we specified that this would be the metacarpus or the third joint in the joint hierarchy list. Not that one. There it is. So that will create a new roll aim locator, but use the metacarpus in its name. Next, we need to move and parent it. So I can copy this and update the comment. Also update the locator name. And we want this to match the position of the metacarpus roll joint. This time we want to parent it to the main metacarpus joint, which is on the driver skeleton. So we can use joint hierarchy here and use the third item in the list, which is actually the fourth, but we put 3. We're parenting it to the main driver skeleton because we want the twist to be available in both IK and FK. Just like we did earlier, we need to move it out too. So let's update the name, and we can keep the rest the same. Now that's created and positioned, we can add the aim constraint. So again, let's copy this. And update the comment. So this time we want the roll joint to point at the joint before it, where we have the hock control. So this needs to be 2. Also update the roll joint name, setting this to 1. Now, the ankle or metacarpus joint is orientated differently. We set it to match the world orientation to make animation easier. So we need to change the axes specified in our flags. As you can see, Y is now the axis which needs to aim at the previous joint. So let's change aim to 0, 1, 0. The axis which is going to look at the locator is X this time, so let's change this to 1, 0, 0. Finally, let's update the name of the locator. Okay, we've added a lot in here, so let's test it to make sure it's working. So the locator is here, but it's behind the leg instead of being out to the side. This is because we moved it along the Z-axis instead of X. I'll just update that. It needs to be a positive number 2. Okay, let's try that again. That's better. We have both locators in position, and the lower one is out to the side. If we rotate the paw control now to test it, as we twist, the roll joint twists with it, which is what we want. If I rotate it forwards and backwards, the roll joint remains steady. The same if I tilt it. So this works well, which is nice as I was expecting some errors. Basically what this setup means is that the lower leg will twist correctly, no matter how the paw is orientated. It just makes movement more natural and means the animator has less to fight against. So all we need to do now is update the hierarchy so the follow joints move with the rest of the rig. All we need to do is parent the follow joints to the main leg group, which we created in an earlier video. This holds all the main systems, and it moves with the leg too. And we will clear the selection. Okay, let's close this and run the script again. So we can't see the follow joints now, but that's because they are hidden. I can see them here in the rig systems group. And that's just connected here so we can control its visibility. But everything is in and it's all working. If we move the root control, the systems move with it too. Okay, let's try the opposite side and see if it works. So it's obviously working and we could leave it like this, but I prefer the systems to be mirrored, just so things look better. We can fix this quite easily in the script though. Let's undo everything and open Charcoal Editor again. So we have these move values and all we need to do is check if we are working on the right side and if so, invert them. Let's go back up to the top of this section and check which side we are working on. We already have a way to do this earlier in the script. Here I can use which side, which gives us the prefix. Where are we? Okay. So if which side is equal to L underscore, we have to use two equal signs if we are checking something. If we just use one, all we are doing is reassigning the which side variable to be something else. Let's use a new variable and call it flip side, and set this to 1. We can now use else because if it's not L underscore, it must obviously be R underscore, and set flip side to -1 this time. We can use flipside to invert our values now. All we need to do is go down to our move values and tell them to multiply by the flipside value. Remember that a value of -1 will invert it. So if it's the right side, they will be inverted. If not, the value is multiplied by 1, so it stays the same. Let's update the other move values too, and the lower leg too. Right, let's try that. Oh, I'll make the systems visible. So the left side looks good. Let's try the right. That's better. Now let's try the front. Okay, update the script first. Okay, they work. And the right side. Perfect. Let's just test the front leg. We haven't done that yet. So I'll switch to FK. So that way works. And that way. And the twist is steady. Cool. Let's look at the ankle. That looks good too. No roll joint movement. We get it on the twist, which is exactly what we want. Okay, perfect. We will quickly test the right leg too. That works. Ankle looks good too. Okay, great. So now we have all the roll joints added to the script. Ah, I just spotted an issue now we are working on the paws. This forward hock area shouldn't be moving with the paw this way. Let's check the outliner. I suspect it's just a hierarchy issue. Let's find the paw control. Okay, there's the problem. The knee control group is following the paw control because it's parented to it. So we need to rethink this. We have to move it out of the hierarchy, but make sure it still follows the paw control, but doesn't rotate with it. Okay, let's undo everything and take a look. Let's find where the knee control group is added. So we need to update this section. Mainly this line, as the section below only works on the rear leg, and that's fine. We no longer want the knee control group parented to the paw control, so let's remove this. Let's add an else statement here, so it will only add this if we are working on the front leg. First we need to move the knee control offset group. Let's parent it to the main root control with all the other controls. We now want it to move with the paw control but not rotate. So to achieve this, we can use a point constraint. I'll just copy this and change it to point. Paw control name is fine here. So we just want to update what's constrained. So let's change this so it's the knee control offset group. Okay, I think that's all we need. So let's try it out. Okay, so everything moves with the paw control, which is a good sign. The hop control works too, which is good. And we can now rotate the paw independently. Perfect. Okay, let's rig the other side. That's done. And now the rear legs. Turn on the system so we can see them. Okay, all works well. They also work with the stretchy joints. So once we are finished, we could go in and turn off the rotational axes. We can just comment this out for now. Okay, so we now have a script which will automatically rig both the front and rear legs on our dog. You can also use this to help speed up rigging other quadruped-based creatures too. So we covered building the main joint chains, adding IK and FK blending. We also included stretchy joints too, and finally added the roll joints. So what I want to do in the next video is add one more system to the script, and what this will do is enhance the stretchiness to give us full volume preservation. Well, we've come to the end of another video. Thanks for watching right to the end, and if you found this video useful, please hit that like button to show your support. While you're at it, you could also subscribe and enable notifications so you're kept up to date with future videos and community posts. If you have any questions or suggestions, please post them in the comments below or contact me through the antCGi Club Twitter account and I will try my best to reply. Alternatively, you could post them in the antCGi Club Discord server where I spend more of my time. You can find an exclusive invitation to join in the description below. Remember that you can also join the antCGi Club to help support future videos while also earning yourself exclusive rewards. Alternatively, if you would just like to show your appreciation, why not treat me to a coffee at my coffee page? The link is on the screen now and in the description below. Thanks again, this is antCGi signing off and I will see you on the next one.